going to continue our interference patterns with the math that goes with it. All right, so here's a problem. I have two speakers that are 3 meters apart. Two speakers are 3 meters apart. And down here, I have a picture of what we've been talking about. I got the two sources, and then they interfere with each other, and I get a central maximum and a first order maximum and a second order maximum, and so on. Down here, I've cleaned it up a bit. Okay, this just shows the two speakers. I'm not showing all the circles because that's going to clutter things up, but I'm showing a central maximum, first order maximum, second order maximum. All right. The math that goes with this is as follows. Okay, the equation is going to be m lambda is d sine theta. Okay, lambda is obviously the wavelength. D is the distance between the sources. So in this case, the speakers are 3 meters apart, so D is going to be 3. M is the number of the maximum that you're studying. And theta is the angle between the central max and the mth max. What I mean by that is if m is 2, because I'm doing the second order maximum, theta is the angle between the second order maximum and the central maximum. If m is 3, it's from the central maximum to the third order maximum. All right, so here's our problem. Okay, we have the wavelength is 0.65. We just said D is the distance between the sources is 3. And in this problem, we're doing central maximum and second order maximums. That's telling me m equals 2. Then I just plug into the equation. M lambda is d sine theta. So 2 times 0.65 equals 3 sine theta. So if I multiply those together, I get 1.3 is 3 sine theta. Divided by 3, and I get 0.433 is sine theta. Then I do the inverse sine. So theta is going to be sine minus 1 of 0.433. And that's going to give me an angle of 25.7 degrees. Now we're going to do a second problem over here. Okay, it's how many maxima are there? Because in my diagram, I drew the central maximum, first order, and second order, but it says this isn't scale, and there might be more maximums. There might be a third, a fourth, who knows? The way to solve this type of problem is set theta equal to 90 degrees, because that's the biggest you can get. So the biggest angle is going to give me the biggest maximum. Okay, and I'm going to solve for m, and then there's going to be one more step after that. So m lambda is d sine theta. So m times 0.65 equals 3 sine of 90. Now the sine of 90 is 1, so this gives me 0.65 m is equal to 3. Divide both sides by 0.65, and I get m equals 4.62. Now, m has to be an integer, so it can't be 4.62. The largest m is equal to 4. So now I know I have a central maximum, first order maxima, second order maxima, third, and 4. So that gives me 9 total maxima. Okay, there's the central max, 2 first order, 2 second order, and so on. So the way to get that number quickly is just take the highest number you have is 4, multiply by 2, so that gives me 8, and then I add 1 for the central maximum, and that gives you 9.